Robotic tentacle targets keyhole surgery. Engineers have constructed a robotic arm, aimed at improving surgical operations and inspired by the Octopus. Just like its aquatic inspiration, the robotic tentacle has no rigid skeleton. It can bend, stretch and switch between flexible and rigid states as required. Its movement is driven by inflatable compartments and its stiffness by a central tube containing the specially selected granular medium, coffee. When suction is applied, the granules jam to create the desired rigidity. The design is published in the journal Bioinspiration and Biomimetics and is the product of a collaborative EU project called Stiff Flop. The latest work was done by engineers in Italy, one of 12 teams involved in the consortium, which is coordinated by King's College London. Ultimately, the researchers hope to develop the device so that it can be used in minimally invasive surgery operations performed via the body cavity or a keyhole-type incision. The human body represents a highly challenging and non-structured environment, where the capabilities of the Octopus can provide several advantages with respect to traditional surgical tools, said the paper's lead author Tommaso Ranzani, from the Sant'Anna School of Advanced Studies in Pisa. He believes the robotic tentacle could trim that number of instruments and simplify operations. The current prototype is 14 cm long and 3 cm across and split into 2 sections. Running the length of each section are 3 cylindrical chambers that can be pumped full of air to varying degrees, lengthening or bending the arm. At the center is another chamber, packed with coarse ground coffee. When air is sucked out of this compartment, the granules jam together and the arm becomes more rigid. Other robotics engineers were impressed by the tentacle's performance but emphasized that it is still a long way from the surgery. There are many laboratories and companies working on special surgical robots, and this effort is still at an early stage.